As we talk about rotations, we're simply looking at taking a shape, like this triangle here, and spinning it around. So rotations have to have a center, a point that you use to spin around. For everything that we do, we're going to use the origin as that center point. So we're going to take this shape and simply spin it around here. You can go this way. We call that counterclockwise because it goes the reverse direction of a clock. Or you can spin it this way, clockwise, the direction of a clock. Now I've set up this little slider here just so we can kind of see how things look. So the shape itself doesn't change. It's still the triangle. It's the same triangle everywhere. But what does change is where its location is and where its orientation are. Now, just to see what's happening, I'm going to take the original triangle and we're going to draw circles through the 3 points that we have on the triangle, just so you can see that as you spin, everything stays the same distance apart. It's the same shape. All that's different is where it is and which way it's facing. So location and orientation can change. Now, for the examples that we do, it's very tough to draw these without tracing paper. We just don't have that here all the time. So what we're going to do is restrict ourselves to some simpler rotations. Basically, just the big ones. Do you go a quarter of the way around, halfway around, or 3/4 of the way around? You can go in either direction, quarter way around, halfway around, or 3/4 of the way around. So let's turn that into some toolkit knowledge. So in a rotation, all your points are spun around a center, and that is called the center of rotation. For us, that center is always going to be the same point. It'll be the origin. When you rotate, the shape's location changes and its orientation changes. As you spin it, it faces other directions. Rotations are described using an angle, how many degrees, and a direction, clockwise or counterclockwise, just so we can keep them straight. Let's start with this direction. So spinning around here, this is clockwise because it's the direction of an analog clock. The other direction is your counterclockwise. When it comes to the amount of rotation we have, we're only going to have these options. If you go 1/4 of the way around, so a quarter turn, that's 90 degrees. A half turn is 180 degrees. And a 3/4 turn, 3/4, is 270 degrees. Now this is important because it turns out there's actually a few different ways to describe a rotation if you haven't seen it happen. Here's what I mean. Let's take a look at this. The original shape is the XYW. The one with the primes, that's your new shape. So this is the new one. This is the old one. What I want you to do then is to say, okay, well, to get from the old to the new, spinning around the center, how do we have to go? I like to start with the simplest way. So from X to X prime, I'm just kind of going like that. Now, describe it. That's 1/4 of the way around. So it's a rotation of 90 degrees and give the direction. Well, this is going this way. So that is a counterclockwise rotation. And we're moving around the origin. That's the center of rotation. And this is all perfectly good. Now, there is another acceptable answer. If you haven't seen the rotation happen, you could have said, well, what if I did this instead? X would spin around that way. You'd still end up in the same spot. A second acceptable response is to say you can rotate 3/4 of the way. So that's 270 degrees clockwise. So 90 degrees counterclockwise ends you up in the same place as 270 degrees clockwise does. So when you're coming to that, your answer key and the practice packet usually uses the smaller angle. But when it comes to our power assignment, either way will be considered okay. So for our examples, center of rotation always going to be the origin, and the angles of rotation, a quarter turn, a half turn, or a 3/4 turn all the time.